Okay, here's what an inequality is trying to do. We're trying to find points that make this true. So for example, let's say I wanted to test the point 5, 1. Okay, the point 5, 1 is right here. It's 2, 4, 5, and up 1. Right there's that point. I want to test to see if 5, 1 makes this true. Well, if I stick, this is the x and this is the y, so where there's a y, I'll put a 1 less than, where there's a x, I'll put a 5, so that's 4 times 5 squared minus 8 times 5. So our asking is 1 less than 5 times 5 is 25 times 4, so that's 100 minus 8 times 5 is 40. So we're asking is 1 less than 60. Well, of course, that's true. So this dot is part of the answer set. So I want that dot to be included. 5, 1 is a yes. 5, 1 is a true. It makes this true. What about, so I want to do that for all of them. What about something like 3, 1 or 3 negative, how about 3 negative 2? 1, 2, 3, 1, like that dot right there is 3 negative 2. Is that in the ball game? Well, let's try it. So I'll put the negative 2 where the y is, less than 4 times 3 squared minus 8 times 3. Okay. 3 times 3 is 9, times 4 is 36, minus 8 times 3 is 24, so is negative 2 less than 12? Well, yes, that's true. So this one is also a yes. What I want to be able to do is test every single point, thousands and thousands of points, and find and dot in all of the yeses. Like try that one, whatever that decimal is. 4.1, negative 1. So I would now want to try 4.1 down 0.2. See if that one is true. So I want to identify all the trues. I want to dot in all of the trues. Okay, well, of course, we're not going to do it one point at a time. What we're going to do is graph the parabola. So I'm going to graph this now. So I'm going to change its form. So I'm going to factor out the 4. 4x squared divided by 4 is just an x squared. Negative 8 divided by 4 is negative 2x. Okay, I need to cut this in half to negative 1. Negative 1 squared. 1 times 1 is positive 1. Okay, I added a 1 times 4, so I really added 4 to this side, so I'll add 4 to that side. So this equation really is y plus 4 equals 4 times, and then factor this, x minus 1 all squared. That's what we just got done doing in the last problem. This 4 really belongs over here, so if I multiply both sides by 1/4, I have this side by 1/4, so really the way I can see it by hand is 1/4 y plus 4 equals x minus 1 all squared. So there's our vertex, 1, negative 4. And it's 1/4 as tall. So all of the y's are going to get, not 1/4 as tall, the inverse of that is times 4. So all the y's will be 4 times as tall. Okay, so I go over 1, negative 4 to get started. Over 1, down 4. So there's the vertex right there. Now, I would go over 1, up 1, but it's the y's are times 4, so I'm going to go over 1, up 4, 2/4 right there, and over 1, up 4. That would be the 1, 1, which turned into 1, 4. Then I would go 2, 4, but the y's getting multiplied by 4, so it'll be 2, 16. So for my vertex, I'm going to go over 2 and up 16. 2, 4, 6, 8, 10, 12, 14, 16. And then over 2, up 16. All right, so there goes the parabola. Now I want to just take a look at these exact dots that are there. Like even this one right here, that dot right there, what now is negative 1, 12. That dot should make this true. So I'm going to test it. The y is 12. 4 times negative 1 squared minus 8 times negative 1. So here I have 12. Negative 1 squared is 1, so that's 4 times 1. This is 8. 8 times -1 is another -8. Gosh, doing subtraction. So I have 12 less than 12. Okay, that's not quite true. I mean, in fact, that's false because it was less than. It was not asking for less than or equal to. So that dot is the borderline, but it's not actually true. So when this symbol occurs, that means we want to go ahead and graph in. It's like the border between Malaysia and Thailand. It's the border. One side is in, one side is out. But the border itself makes it false. So in order to show that the border itself makes it false, we make it a dashed line. The dashed line means these dots right along the parabola do not count. They make it exactly even, and it doesn't want even. Now, we already know that these dots out here work, so because we already tried it. I already tried this 5, 1, so I know that that's true, that's true, that's true. What that means is all of the dots on the outside of this borderline are true. So the way that we indicate that, instead of putting millions of dots, we shade it all in. See, this is like coloring thousands and thousands of dots. It's like saying there, 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 there. All of those dots. And then also over here, everything on the outside of this is true. So you don't have to test them all, you only have to test one. If you get one that's true, that's the side that's true. What if you happen to pick a point that was false? Like let's say I picked this point right there. That point right there is 2, 4, 6, 8. That point right there is 2, 8. What if I would have tried 2, 8 at the beginning? Okay, notice that 2, 8 is not shaded. 2, 8 should be false. So if I put the 8 where the y is, put the 2 where the x is. So I have 8 less than 2 times 2 is 4, times 4 more, that's 16, and then 8 times 2 is 16. See, 2, 8 makes it 8 less than 0. Well, see, that's false. So that one right there is false. This one out here was true. It doesn't matter, you only have to pick one. If the inside is false, it does not get shaded. That means all the insides are false. So all the inside is clear. Well, if the inside is clear, the outside is shaded. Here, if we pick a shade, if we know that the outside is shaded, that means the inside is clear. So you only have to pick one dot. One dot tells you both of them. And then the only little thing that people tend to miss, it's minor, but it's something, is if it's not or equal to, then it's a dashed line. See this one over here? It means the border does count. So when we want the border to count, we want all these dots to be on there so that we'll fill that all in with shade. Okay, so first, hopefully we're getting decent at completing the square. First move, put the 1 over there. So y plus 1 equals. Then we've got to, so that's not there anymore. Now we've got to divide everybody by a half that's left. So 1/2 divided by 1/2 leaves an x squared. 2 divided by a half is a 4. All right, that's the first couple steps. Then we cut this in half and square it in the whole. So cutting that half is 2. 2 squared is 4. So it looks like I added 4 to this side, but it was really times half. So really I only added 2 to this side. I added 2 to this side, I'll add 2 to that side. So after completing the square and all of this stuff, we have y plus 3 equals 1/2. Factoring this, that's why we write down the 2, x plus 2 all squared. I would like to move the 1/2 to the other side. That 1/2 really belongs to the y's. So multiply both sides by 2. So it's 2y plus 3 equals x plus 2. Okay, this means the y's are halved. So instead of going over 1, up 1, I'm only going to go up a half the amount. So our vertex is at -2, -3. Okay, -2, -3. It's right here. I would go over 1, up 1, but I'm only going up a half. So over 1, up a half, over 1, up a half. That's like the 1, 1. Over 1, up 1, but I only went up half. 2, 4. Okay, the y part's getting halved, so it'll really be 2, 2. So over 1, 2, up 1, 2, over 2, up 2. Now, since this one is equal, all of these dots are going to make it like 3 less than or equal to 3. That's true. So all of these dots, if we plugged them in, it makes it the equal part. Well, the equal still makes this true, so in order to indicate that, we make this a solid line. Just like we've put little dots on every single one of those. Those are all dots that make it true. So that's the border. Now the shade, some more trues. There's a whole bunch of trues on the inside, or there's a whole bunch of trues on the outside. It does not matter what you pick. Now, I'll just give you a hint. Here's the one that I like to pick. I like to pick that one right there, because that's 0, 0. 0, 0 is obviously on the inside, so if that's true, all the insides. If it's false, then it's all the outsides. Okay, I picked 0, 0 because it's so easy. If I put a 0 in for y, is 0, oops, that was greater than, so 0 greater than or equal to 1/2 times 0, that's 0, plus 2 times 0, that's 0, minus 1. Is 0 greater than -1? Yes, that's true. So this is a true dot right there. That means everybody with it is a true dot. So if you find one dot that's true, everybody on that side is also true. So the insides make that true. That means I could pick any dot in here, like this one right here. I now know that -3, -1 is true without having to test it. I also know that this dot right there, whatever that is, -4 is false. I don't have to test it. I know if I stick 4s into that original equation, it's false. Okay, number 3, so it's going to be a dashed line. I just basically have to complete the square and get it going. So I'm going to move the 24 to the other side. So y minus 24. Oops, it'll be y plus 24. Less than or equal to. I'm going to divide out the 3. Taking this first term, dividing out the -3 leaves an x squared. 18 divided by -3 leaves -6. Okay, let's finish it off. Got to have the b term, so that's -3. Square it in. -3 squared is +9. Okay, I didn't add 9, I added 9 times -3, so I added a -27 on this side, so I'll add a -27 on that side. So we have y minus 3 less than -3, and factor this. So that's the x minus 3 all squared, and multiply off so that this is to the other side, so the -1/3 is over there. Okay, this means the y's are all multiplied by -3. The vertex is at +3 for the x and +3 for the y. So 3, 3, 2, 3, 1, 2, 3 is right there. It's going to be a dashed line. I would usually go over 1, up 1. But the y's are getting negative tripled, so instead I'm going to go over 1, down 3. So over 1, 1, 2, 3, over 1, 1, 2, 3. Then I would usually go 2, 4, but the y's are getting negative tripled, so that's 2, -12. So from the vertex, I'm going to go over 2, down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and over 2, down 12. It's a dashed line because I do not want the border to count. So this one's going to look like a dashed line. Okay, I can test any point out here, any point in here. The point I'm going to test is right there because 0, 0 to me is the easiest. It's obviously on the outside, so I'm just going to test it. It's either true or false. So I'll put a 0 right there for that y. 0 less than 3 times 0 is 0. 18 times 0 is 0. Minus 24. Is 0 less than -24? That is a false statement. 0 is bigger than -24. So now this point is false. That means all of its neighbors are false. So all of the outside is false. That means all of the inside is true. We're always trying to shade the true side, so we're shading the true. All of these dots in here work. All of these dots out here do not work. All of these dots make it true. All of these dots make it false. Okay, same thing. This will now be a solid line. We want the border to count. Okay, I'll move the 29 to the other side. So y plus 29 is greater than or equal to. So now I'm going to factor out the -2. So I'm going to divide by -2. This term divided by -2 leaves x squared. -16 divided by -2 leaves positive 8x. Cut the middle term in half, which is 4. Square it in. So 4 squared is 16. So right here I added 16 times -2. I really added -32 to this side, so I'll add -32 to this side. Okay, so that leaves y minus 3 greater than or equal to -2. And then when we factor this, that's what the 4 is for. Going to multiply both sides by -1/2 so that that goes away. So this side is times -1/2. So we have -1/2 y minus 3 greater than or equal to x plus 4 squared. This means the y's are multiplied by -2. The vertex, the x part is -4, the y part is positive 3. So -4, 3. There's -4, 1, 2, 3. Okay, I would normally go 1, 1 from there, but the y's are getting negative doubled, so really I'm going to go 1, -2. So from here I'll go over 1, down 2, over 1, down 2. Then I would normally go 2, 4, but the y's are getting negative doubled, so 4 times -2 is -8. So from the vertex, 2, 1, 2, 3, 4, 5, 6, 7, 8, and 2, 1, 2, 3, 4, 5, 6, 7, 8. There's the border. It's a solid line. And now it's either the insides or the outsides. Right here's my favorite point, 0, 0. So 0, 0 is on the outside. Let me see if that's true. Is 0 greater than 0 minus 0 minus 29? 0 greater than -29 is true. So now this point is true, so it's shaded with all of its neighbors. So everybody on the outside is true. Everything on the inside is false. And that is how you graph inequalities.